Dear friends, this video is included in group interview question and recommended answers for interview question of construction plant and machinery engineer. This time, we'll talk about recommended reply 4. How familiar are you with Tier 4 engines and emission control technologies in heavy machinery? Answers. I'm highly familiar with Tier 4 engines and their associated emission control technologies in heavy machinery, as these are now standard in modern construction equipment. Tier 4 regulations, set by the Environmental Protection Agency, EPA, aim to significantly reduce emissions of particulate matter, PM, and nitrogen oxides, NOx, which are major pollutants from diesel engines. Overview of Tier 4 engines. Tier 4 engines are designed to comply with stringent emissions regulations by reducing harmful pollutants from diesel engines in construction machinery like excavators, loaders, and graders. These engines use advanced technologies to meet the emission standards while maintaining performance and fuel efficiency. A. Key emission control technologies in Tier 4 engines. 1. Diesel particulate filter, DPF. Function. DPFs capture and store soot, particulate matter, from the engine exhaust, preventing it from being released into the atmosphere. Regeneration process. Over time, the DPF becomes full of soot, and a process called regeneration occurs, where the filter is heated to burn off the accumulated soot, converting it into ash. Passive regeneration occurs naturally during normal engine operation when exhaust temperatures are high enough. Active regeneration happens when the engine injects additional fuel to raise the exhaust temperature and burn off the soot, typically when passive regeneration is insufficient. Common issues. DPFs can become clogged if regeneration doesn't occur properly, leading to reduced engine performance or the need for manual cleaning. 2. Selective catalytic reduction, SCR. Function. SCR systems reduce NOx emissions by injecting a solution of urea and water, commonly known as diesel exhaust fluid, or DEF, into the exhaust stream. The urea reacts with NOx to form harmless nitrogen and water vapor. Advantages. SCR allows the engine to run more efficiently and cleanly, as NOx reduction happens after combustion rather than during it. Maintenance. Operators need to monitor DEF levels and ensure the SCR system is working properly. Low DEF levels or system malfunctions can lead to reduced engine power or shutdown. 3. Exhaust gas recirculation, EGR. Function. EGR systems reduce NOx emissions by recirculating a portion of the engine's exhaust gases back into the combustion chamber, lowering the combustion temperature and thus reducing the formation of NOx. Challenges. EGR systems can cause increased soot production and may contribute to engine wear if not properly maintained. Clogged EGR valves can lead to poor engine performance and increased fuel consumption. 4. Diesel oxidation catalyst, DOC. Function. DOCs reduce carbon monoxide, CO, and hydrocarbons, HC, in the exhaust by oxidizing them into carbon dioxide, CO2, and water. It also helps with the oxidation of NOx into NO2, which assists in the DPF regeneration process. Maintenance. DOCs are generally maintenance-free, but their effectiveness can be reduced by contamination or poor fuel quality. 5. Turbocharging and aftercooling. Function. Turbochargers increase engine efficiency by forcing more air into the combustion chamber, allowing for better fuel combustion. Aftercoolers cool the compressed air, increasing engine power and reducing emissions. Impact on Tier 4 engines. Turbocharging improves overall engine performance, enabling the engine to meet emissions standards without sacrificing power. 6. Crankcase ventilation filters. Function. These filters prevent oil mist and other contaminants from the crankcase gases from being released into the atmosphere. The filtered gases are then either burned in the combustion chamber or vented safely. B. Challenges with Tier 4 engines. 1. Higher initial costs. The added complexity of Tier 4 engines, with components like DPF, SCR, and EGR, increases the cost of both the machinery and maintenance. 2. Fuel efficiency. While Tier 4 engines are more fuel efficient in some ways, the after-treatment systems, such as DEF usage, can add operational costs. 3. Maintenance and downtime. Tier 4 engines require more frequent and specialized maintenance, particularly for DPF cleaning, DEF management, and sensor calibration. 4. Operator awareness. Proper training is needed for operators to understand how to manage Tier 4 technologies, such as ensuring DEF levels are maintained and responding to regeneration cycles. C. Benefits of Tier 4 engines. 1. Environmental impact. Tier 4 engines significantly reduce harmful emissions, improving air quality and reducing the environmental footprint of construction activities. 2. Fuel savings. When combined with the latest engine management systems, Tier 4 engines can improve fuel efficiency, reducing operating costs over time. 3. Compliance with regulations. Machines with Tier 4 engines are compliant with modern emission standards, avoiding fines or penalties associated with non-compliant equipment. As a maintenance engineer, we are involved in diagnosing and maintaining these systems, performing DPF cleanings, monitoring DEF consumption, and ensuring that the ECU is managing all emissions-related components effectively. Understanding how these technologies interact and the importance of proper maintenance is crucial for optimizing machine performance and minimizing emissions-related downtime. Friends, we have provided recommended reply for how familiar are you with Tier 4 engines and emission control technologies in heavy machinery? If you require a PDF version of the message discussed in this video, kindly leave your name, phone number, and email in the comment box. We will communicate via WhatsApp or email. Also, subscribe to our YouTube channel Inframechanizer, which is completely free.